Okay, welcome back students. So we had started with the number system and I showed you the number system, how it is the human number system, that is the decimal number system, and the digital computer system, that is the binary number system, is different. Computer only understands the binary number system, and so we got introduced to binary numbers. So let us take an example, just some exercise. And so let us convert this decimal number to binary. So please remember, decimal to binary. So if any decimal number has to get converted into binary or to octal or to hexadecimal, which we are going to learn, octal and hexadecimal numbers. So decimal to binary, decimal to octal, decimal to hexa. Please remember that if it is decimal first, then the procedure that we are going to follow is we are going to divide this number. Okay, we're going to divide consecutively, we're going to divide this number. So if it is decimal to binary, now binary, the base for binary is what? The base for binary is 2. So we're going to divide this number. So always remember this. And I'm putting a lot of emphasis on decimal to binary, decimal to octal, because during the exam it becomes a lot of, it creates a lot of confusion. And you were supposed to divide this, but then you did something else with this number, and this happens a lot with students. So I'm saying this, okay, any decimal to binary, decimal to octal or hexa, understand it is going to, the procedure that we are going to use is we are going to divide the number. So if it is decimal to binary, so we are going to divide this number with 2. Please understand why 2, because the base value of binary is 2. Why it is 2? Because there are two symbols we have, that is 0 and 1, and that is the base value of binary. So if we have to convert this 57, so I'm going to divide this with 2, so that is 2 into 2 4, and so 228, that is 56. So what is the remaining? The remainder is 1, isn't it? So then again I'm going to divide this result again by 2, and then it comes down to 214, that is 2 ones are and 2 fours are. You can do it in a simple way also. So this is a simple division, children. I hope I don't have to really explain this, how this division is taking place. So as you're in class 11. Okay, so 2, 14, 28. So 2 ones are, 2 fours are. So the remainder will be 0. So I'm going to write over here 0. And then there is a 14 again. So obviously I'm going to divide that by 7. The remainder will be 0. And that is 2 threes are 6. The remainder will be now 1. And again then it will be 2 ones are 2, so again the remainder will be 1, and at the last it is not divisible, just you have to take that remainder. That is very important, do not forget this. Okay, the last thing, do not forget this. Even this is a mistake that maximum students they make. Please understand that the bottom top approach, that is how the approach should be, and this will be called as the most significant bit. So this is the most significant bit, and this the bottom up approach, and this will be called as the least significant bit. So bottom up approach. So what is the answer for this? The answer is 111001. So that's the binary representation of the number 57. Fine. So this is the procedure, children. Any number if you have, just keep on dividing that number by 2 if it is into binary, decimal to binary. Fine. Now let us approach to the next, that is I'm going to tell you about the another number system, that is octal number system. Now why do we have this octal number system when decimal number system is made for humans and the binary number system is made for digital computers? So where does this octal number system comes from? This is octal number system and the hexadecimal number system. We are going to look at hexadecimal afterwards, but today we are going to look at octal number system. So octal means 8 basically. So there are 8 symbols in this particular number system. Now the reason why we have this number system is because binary numbers are basically the combination of zeros and 1. Okay, something, okay, I have typed 2 over here, just a minute. Okay, so the combination will be something of like this, isn't it? So, you can see that a simple, decimal number system, if you see a simple decimal number system, the answer to that was this. So it's quite a big number. The stream is large basically, just for 57. Imagine if there are some bigger decimal numbers. So this stream of the bits will be very large. The stream of ones and zero will be very large. So it is very difficult to design the circuit basically. So what is a circuit? Basically, that is the microprocessor chip. Any circuit designing, even in physics, you might be having a circuit designing. You're going to come across with that also. So if you have to design a circuit, though we are not going to use in physics, there is octal number system or something of that sort. But I'm saying in real world, basically any circuit is to be designed. So we cannot do that circuit designing with a stream of ones and zeros. We require a better number system so that we can represent this binary number in a kind of a short form, you can say. So for circuit designing, children, we have two number systems, that is octal and hexadecimal number system. And let me tell you, decimal to binary, it's the conversion is very complicated. Please understand why it is complicated, because we have to keep on dividing and then we will get the answer for it, isn't it? But or the vice versa, binary to decimal is also a bit complicated. But understand that binary to octal and octal to binary is very easy. Now this conversion is pretty easy and we're going to see that in the future. But today we are going to understand the octal number system and how a decimal has to be converted into octal. That is what we are going to see today. And then later on I'm going to prove this point, that how easily a binary can get converted to octal and octal can get converted to binary. The conversion is super easy. Okay. So octal, as I said, there are 8 symbols, that is 0, 1, let me just take this series now, and till here, that is 7. So 0 to 7, that is an octal number system. So what does this mean? This means that I cannot have any number if it is an octal number system. So for example, can I have the number like 578 and I say that this is an octal number? No, this cannot be an octal number, because you can see that there is a symbol, that is 8. So if there is 8, octal number system cannot have this symbol. There are only 8 symbols, that is 0, 1, 2, 3, 4, 5, 6 and 7. These are the 8 symbols you have to use to form an octal number system. So if it is 578, so that is not a octal number system. Okay, so if I say 7, okay, 7, and then what comes next after 7? How I can have 8 out here? That is a question. So obviously I'm going to go with the same approach. Is I'm going to have the combination, that is I'm going to have 1. So I'm going to have over here, okay, I'm going to have, that is next number, that is 1, and then I will start again with 0, and this I'm going to type it till here. Okay, just a minute, then 11 and till 27. So the next series will come, that is 10 and till 17. What will be my next series? That is 2 7, sorry, 2 1, isn't it? Then it will be 2 2 and so on. So I'm using the same method that we did in the first. Okay, now over here, okay, this is 0, sorry, 2 0 and 2 1. So this is the same approach that we did in the first class, isn't it? So 8, this is 8 in decimal, this is 9. Okay, we can prove this. So if we have to, what we did for the binary, for example, there was a decimal number and we converted that into binary using what? Dividing that by 2, right? The same approach. Now if it is 10, okay, or for example, okay, this is okay, this is okay, we'll see that. I'm going to prove this is 8 actually, isn't it? So this is 10, sorry, 8, okay, 8, and 8, this is decimal number 8, and if I have to convert this into octal, okay, decimal to octal. Now please understand, decimal to binary, what you did, what we did, we divided by 2. Now decimal to octal, what we are going to do, divided by 8. The base value is 8. So if I divide by 8, that is 8 ones are 8. What is the remainder? That is 0. And then 8 again is not divisible. So what is going to be? We are just going to take that 1 over here. And the same bottom up approach, that is 1 0. So the answer is 1 0, isn't it? So the decimal number 8, if we convert that into octal, that is what? That is 10. So you can see after 7, if I consider this as decimal, 7 8 9 10 11 12, this is how it goes, children. Okay, you can use this method and then you can check whether this is right or wrong. The same combination, 0 to 7, then I used 1, then 0 to 7, then I used 2, you can see 2, and again 0 to 7, the same combinations that we are using. This is the same combination for the decimal number system, the same combination for the binary number system, and the same combination it is for the octal number system. So again, okay, this is, if I say this is 8, 9, 10, 11, 12, 13, 14, and 15. This is 15 decimal. Octal is 17, and this is 16, isn't it? This is 16. So if it is, for example, okay, let's just have 20 as decimal number. Sorry, this is okay, there are 15. Okay, 15 decimal number system. Now if I have to, convert this, okay, so how I'm going to do this? So that is 8 ones are, I have to divide that by 8. Ones are 8, I cannot divide it by 2. So if I divide it by 8, so what is the remainder? Remainder will be 7. Okay, it is going to be 7. So 7, and then again it is 8 is not divisible, and then it will be 1. So what is the answer for this? It is 17, isn't it? And so you can say 7, this is 8, that is the decimal, 8 9 10 11 12 13 14 15, and this is 16, right? So okay, this was, I took 15, isn't it? So sorry, this I took 15, so that is 8 9 10 11 12 13 14 and 15. So this is 15, isn't it? So if I divide 15 by 8, it comes down to what? It comes down to 17. So 15, if I convert that into the decimal, okay, please understand, I'm talking about decimal, and these are the octal numbers. So after 7, comes 8. So this is 8, and in octal it is 10. Okay, hope you are getting it. Then 8 9 10 11 12 13 14, and this is 15, that is for the decimal, but in octal it is 17, and this is how we proved the point. So if we have to divide this by 8, it is going to come down to 17. So this is how the whole approach is. I just took the another numbers. Okay, it's okay. So anyway, so this is the octal number system. So if you want to take some more examples, I have this in the, this was just a minute over here, the same number I took, that is 57. So obviously I'm going to divide 57, that is a decimal to octal. Okay, 57 is a decimal to octal. What I'm going to do, I'm going to divide that by 8. So that will be 8 7 just straight away, that is 56. Remainder is what? That is 1, and then this is not divisible, so I'm going to take 7, so it is 71. So I converted 57 decimal to octal. The answer that comes down to be, that is 71. So this is how you're going to convert the numbers, children. And so I hope this is very much clear to you. Now I'm going to give you some exercises, and remember again the word, when the decimal word comes first, decimal to binary, decimal to octal, what you're going to do, if it is decimal to binary, divide by 2. If it is decimal to octal, divide by 8, isn't it? So decimal word comes first, then we are going to approach, it will be, we are going to divide the number. So please, I'm repeating this, and I'm pretty sure in the future there will be a lot of confusions, because then we are going to go for a lot of conversions. The first approach will be decimal to binary, binary to decimal, binary to hexa, hexa to binary, binary to octal, octal to binary. So there will be a lot of confusion. So I'm repeating this again and again, isn't it? So children, so that's it. I'm going to give you some exercise to do it in your fair copy for the decimal to binary and decimal to octal. Just do that. It's very simple calculations, and you can do it. Okay. So I'm keeping it short for today. So we're going to meet tomorrow. Bye for now.